Hello students, in today's lecture video, we shall discuss about concrete. I am Soumya Sahu, lecturer in Civil Engineering at SKDB Government Polytechnic, Rourkela, and this video lecture is prepared for the third semester Diploma Civil Engineering students. In today's lecture video, we shall discuss about the definition of concrete, the composition of concrete, what is water cement ratio, and what do you mean by workability of concrete. So let's see one by one the contents. So concrete in construction consists of fine aggregate and coarse aggregate that is bonded together by cement and water. Fine aggregate means sand and coarse aggregate means the gravel. So basically concrete is a mixture of fine aggregate, coarse aggregate, cement and water. Composition of concrete. Portland cement has remained the dominant cementing agent used in concrete production, and aggregates are generally designated as either fine aggregate or coarse aggregate. And all the aggregate materials must be clean and it must be free from admixture with soft particles or vegetable matters, because even small quantities of organic soil compounds result in chemical reactions that seriously affect the strength of the concrete. Depending upon the proportion of cement, fine aggregate, that is sand, and coarse aggregate, that is your gravel, there are different grades of concrete. So, the different grades of concrete are M5, M7.5, M10, M15, M20, M25 and M30. Wherein M5 grade concrete, the proportion of cement, sand and gravel is 1:5:10. For M7.5 grade concrete, the proportion of cement, sand and gravel is 1:4:8. In case of M10 grade concrete, the proportion of cement, sand and gravel is 1:3:6. For M15 grade concrete, the proportion of cement, sand and gravel is 1:2:4. For M20 grade concrete, the proportion of cement, sand and gravel is 1:1.5:3. For M25 grade concrete, the proportion of cement, sand and gravel is 1:1:2. For M30 grade concrete, the proportion of cement, sand and gravel is 1:1:3. Where the letter M stands for mix. Water-cement ratio. The water-cement ratio is the ratio of the weight of water to the weight of cement used in a concrete mix. So, a lower ratio leads to higher strength and durability, but it may make the mix difficult to work with and form. For different grades of concrete mix, different water-cement ratio are suggested by our Indian Standard Code. So for M30 grade concrete, the recommended water cement ratio is 0.45. For M20 grade concrete, the recommended water cement ratio is 0.55. For M25 grade concrete, the recommended water cement ratio is 0.50. Next, we will discuss about the workability of concrete. So, workability of concrete is a broad and subjective term describing how easily freshly mixed concrete can be mixed, placed, compacted, and finished with minimal loss of homogeneity. So, in general, you can describe workability as the ease with which you can work with the concrete. So there are different tests conducted to find out the workability of concrete. They are slump test, compaction factor test, flow table test, VV consistometer test, and Kelly ball test. So one by one we will see all these tests.
The ease with which one can work with concrete is called workability. This can be measured using a simple test called the slump test. Let me show you the procedure. Slump cone test is a simple and popular test extensively used at sites to assess the workability of the concrete mix. The test should be conducted at the commencement of the concreting operations or whenever the workability of the concrete changes. The apparatus for conducting the slump test essentially consists of a metallic mold in the form of a frustum of a cone with a base plate. A steel tamping rod of 16 mm diameter and 60 cm height is to be used for compacting. The internal surface of the mold should be thoroughly cleaned of moisture and any hardened concrete before commencing the test. The mold is placed on a smooth, horizontal, rigid and non-absorbent surface. It is then filled in 4 layers with the thickness of each layer being approximately 1/4 of the height of the mold. Each layer should be tamped 25 times evenly using the rounded end of the tamping rod such that strokes are uniformly distributed over the cross-section. After the top layer is tamped, the concrete is leveled with a trowel so that the mold is filled exactly to the top. The mold is then removed by raising it gradually. The concrete will subside. This subsidence is known as slump. This operation shall be carried out without any jerks or vibrations and within a period of 2 minutes after completion of final tamping. The difference in level between the height of the mold and that of the highest point of the subsided concrete is measured. The subsidence measured is the slump of the concrete. The slump may either be a true slump, a shear slump, or a collapsible slump. The true slump is the desired form of slump that we require. In harsh mixes, the concrete slides down in an inclined plane. This is known as shear slump. In collapse slump, the concrete collapses as soon as the cone is removed. It usually occurs in very wet mixes. The concrete demonstrating a shear or collapse slump is considered unsatisfactory. In case of slump results beyond the specified limits, the mix proportion needs to be adjusted, especially the water content. The slump can also be varied by changing the proportion, size, and combination of the various sizes of the aggregates. It is advisable to assess the workability of concrete mix using a slump cone. Ensure that the cone is filled in a proper manner as indicated. Notice the type of slump. Shear and collapse slump are undesirable. Adjust the slump to the desired value by changing the proportion.
So students, from your exam point of view, the dimension of the slump cone is very important. The slump cone of bottom diameter 20 centimeter, top diameter 10 centimeter and height 30 centimeter is used for the slump test, and 3 layers of concrete are put into that slump cone and each layer is stamped 25 times with the help of the tamping rod, which is having a diameter of 16 millimeter and a length of 60 centimeter. And then we have to find out the subsidence of the concrete under gravity, and it is expressed in millimeter. Next, we will watch the video describing the compaction factor test.
Test on fresh concrete by compaction factor. At the end of this lesson, you will be able to define compaction factor, demonstrate the test on fresh concrete by compaction factor, explain the advantages and disadvantages of compaction factor test. We all would have performed this activity at our home, that is, filling up a container. Assume that you are trying to transfer the grains from the rice bag to a container. You lift the bag and place it close to the mouth of the container and allow the rice to fall into the container. After filling 3/4 of the container, you will try to compact the filled rice by shaking the container, won't you? In the same situation, what if the rice is poured into the container from a particular height? While falling from a certain height, the grains get compacted internally due to the gravitational force applied. Then, you shake the container externally. When you compare both the conditions, external energy for the first condition is more than the second condition. Do you know the reason for this? It is because the grains that fall from a certain height get compacted internally, and then you shake the container externally. Likewise, when the concrete is made to fall from a certain height, concrete gets compacted internally and then a lesser amount of external force is applied to compact the remaining concrete. Thus, its compaction efficiency will be more. The test which considers this factor is called as compaction factor test. Slump cone test is generally used for determining the workability of highly workable concrete, whereas compaction factor test is used for determining the workability of less workable concrete. Now, let us discuss about the compaction factor test in detail. As per IS 1199-1959, compaction factor test apparatus consists of 2 conical hoppers and a bottom cylinder. The inner surface of the conical hoppers is smooth and attached to the trapdoors. The upper hopper's top internal diameter is 254 millimeters. Bottom internal diameter is 127 millimeters and internal height is 279 millimeters. The lower hopper's top internal diameter is 229 millimeters. Bottom internal diameter is 127 millimeters and internal height is 229 millimeters. The vertical distance between the 2 hoppers is 203 millimeters. The bottom cylinder's internal diameter is 152 millimeters and internal height is 305 millimeters. The vertical distance between the lower hopper and bottom cylinder is 203 millimeters. Apart from that, a tamping rod of size 16 millimeters in diameter and 610 millimeters in length is used to compact the concrete. For example, let's take M15 grade concrete. Prepare the mix using 1 part of cement, 2 parts of fine aggregates, and 4 parts of coarse aggregates. The water content is calculated based on the water-cement ratio, generally varying from 0.4 to 0.6. Now, mix the fresh concrete. The inner surface of the hoppers and the cylinder is made free from moisture and greased. Close the trapdoors of the hoppers. Then, measure the empty weight of the cylinder, that is W1 kilograms. Fill the fresh concrete on the top hopper using a trowel without compacting it. Then, the top hopper trapdoor is opened. Thus, the concrete falls on the lower hopper. Gentle tapping is done using a tapping rod to push the remaining concrete from the top hopper to the bottom hopper. When all the concrete has fallen on the bottom hopper, remove the bottom hopper's trapdoor and let the concrete fall into the cylinder. When the bottom cylinder is filled with concrete, remove the excess concrete from the top of the cylinder using the trowel. Then clean the sides of the cylinder properly. Then measure the weight of the cylinder with partially compacted concrete, that is W2 kilograms. Then the cylinder is emptied and the concrete sample is filled again by filling it in 3 layers. Each layer is compacted by giving 25 blows using the tamping rod. Now, the concrete inside the cylinder is fully compacted. The weight of the cylinder with fully compacted concrete is taken as W3 kilograms. Compaction factor is determined using a formula, which is the ratio of weight of partially compacted concrete to the weight of fully compacted concrete. That is, the ratio of W2 minus W1 to W3 minus W1. The value of compaction factor varies from 0.7 to 0.95 based on the workability of concrete. The major advantage of the compaction factor test is it is used to calculate the workability of concrete with low water-cement ratio. And the limitations of this test are it is suitable only in the laboratory, and the apparatus and maintenance cost is comparatively high. Summary: compaction factor test is used for determining the workability of less workable concrete. Compaction
So students, if the compaction factor value varies between 0.7 to 0.8, it is considered as a very low workable concrete, and if the compaction factor value varies between 0.8 to 0.85, then the concrete is considered as low workable, and if this value ranges between 0.85 to 0.95, then the concrete is considered as medium workable, and if the compaction factor value is more than 0.95, then the concrete is considered as highly workable concrete. Let's watch another video.
VB consistometer test for concrete. VB consistometer test is used to determine the mobility and compactability of concrete. The VB consistometer test consists of a vibrator table resting upon elastic supports, a metal pot, a sheet metal cone open at both ends and a graduated rod connected with glass disc. The entire setup is shown on the screen. For dimensions of the various shapes are designed based on the IS 11991959. Today, we are not going to concentrate on dimension. Let us now start with the procedure. Place the slump cone inside the cylinder. Now, fill the concrete in 4 layers. Each concrete is 1/4 of cone height and tamper the surface 25 times. Once filled, struck off the excess concrete. Move the glass disc attached to the swivel arm and place it on the slump cone such that it touches the top of the concrete level. Note down the reading in the graduated rod. Next, remove the cylindrical cone by raising the cone slowly in the vertical direction. Again, place the glass disc and determine the reading. Now, switch on the electrical vibrator and at the same time switch on the stopwatch. The concrete will start to spread in the cylinder container. Continue the vibration until the concrete is remolded and the surface of the concrete becomes horizontal. Stop the vibration and stopwatch. The time in the stopwatch denotes the workability of concrete. The time is expressed in VB seconds. Calculations in VB consistometer. Initial reading in the graduated scale before remolding in. Final reading in the graduated scale after remolding in. Slump value is equal to a minus Pm. And the consistency of the concrete is measured in VB seconds. The workability conditions with respect to VB time are displayed on the screen. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like.
Kelly ball test for concrete. Kelly ball test is a simple type of field test used for determining the workability of concrete. The apparatus consists of 15 cm diameter metal hemisphere weighing 13.6 kg is attached to the graduated stem with handle. The entire setup slides through a frame which is made to rest on the fresh concrete. The concrete sample is taken in the container such that the minimum depth of concrete must be at least 20 cm and the minimum distance from the center of the ball to the nearest edge of the concrete should be 23 cm. Once the concrete is filled, the surface of the concrete is leveled off. The setup is kept on the concrete by holding the handle of hemisphere such that the frame touches the surface of the concrete. Now, the ball is released on the surface of the concrete. The depth of penetration is read immediately on the stem to the nearest 6 mm. Similarly, another 2 measurements are made on the same sample and average is taken as the slump value. The advantages of this test are that it can be performed on the concrete placed in a site and greater precision than slump test. The disadvantages are that it requires a large sample of concrete and it cannot be used when the concrete is placed in the thin section. Thank you for watching. Stay tuned.
Students, let's watch another video describing flow table test.
Flow table test for concrete. flow table test is generally done in the laboratory to determine the fluidity of concrete. The apparatus consists of mold should be made of a smooth metal casting, in the form of the frustum of a cone with internal dimensions of 25 cm base diameter, 17 cm upper surface diameter, and height 12 cm. And the flow table about 76 cm in diameter over which concentric circles are marked. Let's now see step-by-step procedure to do this test. The tabletop is cleaned of all gritty material and is wetted. The mold is placed in the center of the table, firmly held, and is filled in 2 layers. Each layer is rodded 25 times with a tamping rod. After fully filled, the excess concrete is leveled off. Now, lift the mold vertically upward. You will notice concrete stands in the shape of the mold. The table is then raised and dropped 12.5 mm 15 times in about 15 seconds. The diameter of the concrete spread is measured in about 6 directions to the nearest 5 mm and the average spread is noted. The flow of concrete is the percentage increase in the average diameter of the spread of concrete over the base diameter of the mold. Flow in percent is calculated by dividing spread diameter in centimeters minus 25 divided by 25 into 100. Thus, the value of flow percent is calculated from 0 to 150%. A close look at the pattern of spread of concrete can also give a good indication of the characteristics of concrete, such as the tendency for segregation. Thank you for watching.
Next, we shall discuss about the factors affecting the workability of concrete. So, the following are the factors that affect the workability of concrete: water content, mix proportion, size of aggregates, shape of aggregate, grade of aggregate, surface texture of aggregate, use of admixture, use of supplementary cementitious material, time and temperature. So students, let's discuss about all these factors affecting workability of concrete one by one. Water content is the most important factor of workability, and workability increases with the increase of water content. The next one is the mix proportions. So rich concrete mix is more workable because due to sufficient cement aggregates will have proper lubrication for the ease of work. Size of aggregates. So finer particles require more water for a larger surface, and hence aggregate with finer particles need more water to make it workable. On the other hand, bigger particles have less surface area, demand less water for wetting surface, and require less amount of paste for lubrication. So bigger particles give higher workability for fixed water content. Then next factor affecting workability is the shape of aggregate. So irregular shape of angular aggregate demand more water than the round shaped aggregates. For fixed volume or weight, rounded particles have less surface area and less voids, and thus they have less friction resistance too. Hence, round shaped aggregates show higher workability than the angular aggregates. Next factor is the grading of aggregate. So well-graded aggregates tend to fill up the voids and easily get workability. Less amount of water can make it workable. Next factor is the surface texture of aggregate. The aggregates with smooth surfaces are more workable than roughly textured aggregates. Roughly textured aggregates show high friction and segregation tendency. Besides, next factor is the use of admixtures. So there are some admixtures which can improve the workability. Some admixtures are mixed intentionally to increase the workability of concrete. The next factor is the use of supplementary cementitious materials. So there are many supplementary materials used for improving the quality of fresh concrete, and some of the examples are like fly ash. The next factor is time. Fresh concrete stiffens with time and loses workability, though it is not exactly settling or getting strength at all. After mixing concrete, some water is absorbed by aggregate and some may be lost by evaporation, and some may be spent for initial chemical reactions. Next factor is the temperature. So high temperature reduces workability and increases slump loss. Slump loss is less influenced by temperature in stiff mixes because this type of mix is less affected by a change in water content. Students, lastly in this lecture video, I would like to discuss about segregation and bleeding. Segregation is defined as separation of the constituent parts of a concrete mix so that the mix is no longer in a homogeneous and stable condition. Next term is bleeding. Bleeding is the separation of cement and water from the mix. So in today's lecture video, we have covered the definition, composition, water-cement ratio, and workability of concrete. Thank you, students. So if you have got any doubts after watching this video, you can post your doubts in the official WhatsApp group.